I'm back. Okay, today we're going to go over solving multi-step equations, okay? We've been doing this for a while already, but this is where we get special answers, okay? So in class we went over the past 2 days, the past 3 videos, we've been getting only one solution. But what happens if you get special answers? Maybe you get something called no solution. Maybe when you have infinitely many solutions, okay? So let's check some of these out. So first of all, let's go over a simple problem. Let's say 4x plus 6 equals, I don't know, 8x minus 10. This is something that you sure already know how to do. Okay, so same thing, draw your barrier. Click, 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 click. Which one's bigger? The 4x or the 8x? Remember, you always want to try to get the biggest variable. So it's the 8x. So that's the biggest variable. So we need to bring this one, jump the fence, and come this way. So the opposite of a positive 4x is a negative 4x. Negative 4x. This cancels out. Don't put 0x. Once they cancel out, it's 0. Don't put 0. 8 minus 4x is just 4x. Drop this, drop this. Okay? Let's drop them on the same spot. So that's positive 6 here. Drop the equal sign. Drop the negative 10 right here. Okay? Keep on going. We're almost done. Circle the variable. There it is. Draw the barrier. Now, focus on the side where the variable is at. This is on the right side. So who's not inside the bubble? Well, the minus 10 is not inside the bubble. So we do plus 10, plus 10. These cancel out. 6 plus 10 is 16 equals 4x. We're almost done. Divided by 4, divided by 4. So x is equal to 4. That is what we call one solution. We only got one solution, and that solution is 4. That's what we've been doing for the past 2-3 days, like I said. That's one solution. Now let me introduce you to the special cases. Copy these down. Let's say it is 5x plus 8 equals 5x plus 8. Okay, right off the bat, you should be able to see that this looks special. There's a special case. What do you notice? Hopefully you're like, well, there's the same variable and the same number or the same coefficient in front. So 5x and 5x. And then you're like, well, it's the same number here too, which we call the constants, 8 and 8. They're identical. When we get this case, I call it, oh, this is your twins. You have identical twins because you have a 5x and you have a 5x. Every time you have twins, you're going to have a special case. And you're going to see what one of these special cases are. So remember how we always say, circle the big variable. Well, which one's bigger? They're the same. Choose whatever. It doesn't matter which variable you choose. I always choose this one on the left. Like I said, it doesn't matter. Draw your barrier. We have to get rid of this positive 5x. The opposite is negative 5x. So minus 5x, minus 5x. Okay? Then this cancels out. That cancels out. Do not say it's 0x. It's not 0. Once it cancels, it's done. Wait. This cancels out. This cancels out too. Do not put 0x. Once it cancels, it cancels. Drop this. Drop this. So then you have 8 is equal to 8. This is a special case. Now, is 8 equal to 8? Is this a true statement or a false statement? Well, it's true because 8 is equal to 8. Whenever you have a situation in which a number is equal to a number, then we call this many solutions. You have many solutions, okay? In high school, sometimes they call it infinitely many solutions, same thing. But once you get a special case like this, you need to state it, okay? Hold on. Something's going on with the iPad. Okay, we're back. Okay, so like I said again, when you have a number is equal to a number, that's what we call many solutions. It's a special case, okay? And a lot of you guys are like, well, I still don't get it. What do you mean many solutions? Why is that? Let me explain to you why. In class, don't copy this. This is just showing you why it's called many solutions. Let me recopy the problem. In class, I was like, okay, pick any number for x. Any number. And you guys are like, okay, I told you to pick an easy one too. 2. So then I'm like, okay, let me pick 2 here. Instead of the x, I'm going to substitute a 2 in. Okay? 5 times 2 is 10 plus 8. That will give me 18. Do it on the other side. 5 times 2 is 10 plus 8 is 18. You notice that for any value you put in for x, you're always going to have this kind of situation in where a number is equal to a number, or a number is equal to itself, where you get a true statement. This is called many solutions. And that's why if you put any number, 0, negative numbers, 1,000, you'll still get something like this. That's one of the situations, or one of the scenarios, many solutions. Now let's go over something, a problem that's another special case. Let's say negative 6x minus 8 equals 9 minus 6x. Okay? Let's look at this problem. First of all, you look at it and ask yourself, do I have a special case? Do I have what we call twins? Okay? Do we have the same number or the same coefficient in front of the variable? Well, this is minus 6x. This is also minus 6x. That means you have a special case. Okay? You have not identical twins though, because these numbers are not the same like the last problem. Everything needs to be the same to get identical twins and then get many solutions. This is like more of fraternal twins. Okay? So let me see how this works. Circle the biggest one. It doesn't matter. I always circle this one like I said. That was minus, so the opposite of a minus is positive. Positive 6x, positive 6x. That cancels out, cancels out. Do not put 0x. 0x does not exist, so don't put 0x. That cancels out with this one, right? So drop this, you have negative 8 equals to positive 9. Let me ask you this. Is negative 8 equal to 9? Are these two numbers the same? No, they're not. This is a false statement. Every time you have a false statement, the special case is no solution. So every time you have a false statement, it's no solution. And yes, you have to write, when you get something like this, you have to write, well, there's no solution to this problem. Okay? So those are the 3 types of cases that we have. You get one solution, you get no solution, and then you have many solutions. Now let me just quickly summarize, okay? Copy this down in your notebook, like you did this problem. This is a summary. If you get x equals to a number, that is what we call only having, well, let me change this, okay? Let's say 5. I solved the problem, solve, but I got x is equal to 5. This is having one solution, okay? That's one of it. What happens if I solve the problem and I get 6 equals to 6? This is what we call many solutions because the numbers are identical. Let's say we get something like negative 6 equals to positive 6. Yeah, this is a lot of you guys were confused with this. A negative 6 and a positive 6 are not the same. They're totally different. On a number line, that's 0. Negative 6 is over here. Positive 6 is over there. So they're not the same. So they're not the same. Therefore, this is what we call no solution. Got it? So those are the 3 special cases that you will see not only in 8th grade, but all throughout high school when you're dealing with equations. One solution, many solutions, and no solution. We are going to do some more similar problems like this when we get into system of equations, when we might have many solutions or no solutions. And that's all about times. But don't worry about that. We still need a couple more weeks to reach that. Just want to bring something up that came up on the class. Some of you guys might get this. X equals 0. That is having only one solution. A lot of people say, oh, because it's 0, it's no solution. Not. Because x equals 0. X equals something. When x equals something, it is one solution. So this is what we're going to do. I'm going to give you guys a bunch of problems right now, and I want you to copy them on your notebook. I don't want you to solve them. What I want you to do is just identify. Are you going to have one solution, many solutions, or no solution? And I'm going to show you a trick to figure that out quickly. Some of you guys will probably know the trick already. So here we go. Let me write a couple of them down. See if you get them right. Number 1, 3x plus 6 equals 3x plus 6. Number 2, negative 5x minus 4 equals 5x minus 6. 3, let's say 8 minus 9y equals 9 minus 9y. Number 4, 8w plus 3 equals 3 plus 8w. 5, let's give you guys negative 4x minus 9 equals 5x plus 3. I will do it like in class. Let me give you guys 3 minutes. Go decide if it has one solution, no solution, or many solutions. Technically, at this point, you should be pausing the video and testing them out. Okay, now the 3 minutes are up. Hopefully, you already pressed play to see if you get them right. So, are you ready? Let me show you a trick, easy, to show you, like, to see if it's one solution, many solutions, or no solutions quickly. Let's look at the first one. First thing you ask yourself is, do I have a twin situation happening? Are the variables identical? Heck yeah, they are. They're the same. So eventually, the twins will destroy themselves, and you're going to end up getting 6 equals to 6. Is 6 equals to 6? Yeah, it's a true statement. Whenever you have a true statement, you have many solutions. So this is many solutions. Let's go to the next one. Do I have a twin situation happening here? Well, I have negative 5 and I have positive 5x. Is a negative 5 and a positive 5x the same thing? No, they're not. So I don't have twins. When I don't have twins, that means I don't have a special case. I could solve it. I'm not going to solve it, but this one is one solution. And you know what? If you solved it, let me tell you what the answer is. You're going to get a fraction. That's 10 plus 4, that's 2. So then your answer is going to be x equals 2 over 10, which is 1/5. Just in case if you solved it. Next one. Let's go over this one. First thing you ask, do I have twins? Oh, yes, I do. Here are my twins. Negative 9y and minus 9y. Same thing. Cover this up. Cover this up. Eventually, I'm going to have 8. Look, I could just do this. Click. These erase. These erase. Have 8 equals 9. They're not the same. So this is a no solution problem. Okay, let's go look at this one. Ask yourself, do you have twins? Well, I have 8w. Have 8w. They're both positive. Yes, I have twins. Eventually, the twins will cancel out. Cancel. Cancel. And I'm going to be left with 3 equals 3. So this one is a true statement. This one will have many solutions. Many solutions. Let's look at the next one. Easy, right? This is simple. You have negative 4x and a positive 5x. Are these twins? Heck no. They're not twins. That means you could actually solve this. That means you will have one solution. So you only have to write one solution. But if you did solve it, let me tell you what the answer is. You'll do plus 4x, that's 9x. Then you will do minus 3, that will give you minus 12. So x will equal to negative 12 over 9. And then if you reduce, you're going to get negative 4/3. Okay? That's it. Okay? That was the lesson the day before about special solutions. When you have many solutions, no solution, and one solution. This is simple. But once I throw in some distributive property, some combining like terms, it's not going to be so easy to distinguish. It's easy to distinguish how many solutions when it's like this. But once, like I said, once I throw distributive property, combining like terms and fractions the next couple of days, it's going to be a little bit harder, but now you have an idea of how to identify the solutions. And that's it for today's video.